Hello, everyone, and welcome to the last talk of the day. I appreciate you all coming. I hope that you feel invigorated by the GraphQL by the end of this. So my talk today is about introducing and scaling a GraphQL BFF. And I'm hoping that this talk will have something for people who have already adopted GraphQL and might have been using it in production for a while, and hopefully will help you think about what you want to do next with that architecture. But I also hope that if you are thinking about using GraphQL or you want to know more about it, this will give you some ideas about the benefits that might be in store for you if you do decide to use GraphQL. So this is a talk about growing a GraphQL API, much like a plant. So we're going to talk about what it's like to introduce GraphQL to a code base. And we're also going to talk about what it's like to use GraphQL in production for a year or two, and how your architecture might evolve. So I'm going to take you on the journey of a GraphQL API that I've built with my team at Conde Nast, and ultimately what's happened to it over the course of just over 2 years. And I'm specifically talking about the Backend For Frontend pattern, which some of you may have heard of, and if not, it's okay, I'm going to give a crash course. And I'm talking about this not just because it's what I built at Conde Nast, but also because in the industry, this is quite a common pattern for adopting GraphQL, and there are a lot of people out there with GraphQL BFFs. So I wanted to give a talk that goes a little bit beyond GraphQL 101 because GraphQL is no longer a bleeding edge technology, and there are a lot of people out there who have already adopted GraphQL and are starting to feel the need to scale their APIs. So if you have GraphQL in production, there's a lot for you, and if not, then there'll be something for you as well. So here's what I'll be talking about. My talk is split into 4 sections. The first section will be a quick introduction to GraphQL and the BFF Design Pattern. So I know some of you will already be familiar with these concepts, but I'm going to get us all on the same page regardless. Secondly, we're going to talk about building a GraphQL BFF, how GraphQL and the BFF design pattern relate to each other, and what it's like to actually build a GraphQL BFF. Then I'm going to talk about some problems or opportunities that might arise with this architecture, and how you ultimately might want to scale your GraphQL BFF. And finally, I'm going to talk about the future of GraphQL architecture, some industry trends, and where we ultimately might want to evolve our GraphQL architecture. All right, who am I? I'm Michelle. This is a photo of me. I'm a software engineer at Conde Nast in London, and if you want to tweet me about GraphQL or BFFs, you can do so right there. All right, section 1, an introduction to GraphQL and BFFs. We're going to start with GraphQL. So many of you will already know about GraphQL, but I want to give a quick 101 regardless. Can I ask for a show of hands how many people are using GraphQL in production here? Okay, it's like a quarter, a third. This is good. This is a good mix. All right, so let's talk about what GraphQL is. Here are a few definitions. If you go to the official GraphQL website, the documentation will tell you that it is a query language for APIs. I also quite like the definition of a language for requesting remote data. And finally, you've probably heard GraphQL talked about as the cool, popular new alternative to REST. And this is a definition that I think encompasses all of that from How to GraphQL, which is a great website for learning how to GraphQL. It's howtographql.com. So they say GraphQL is a new API standard that provides a more efficient, powerful, and flexible alternative to REST. And here are some things that GraphQL is not. GraphQL is not a database language, and it's not related to graph databases in any way, and it's not anything to do with Neo4j. So it is a query language for APIs, not for databases. It provides an interface to describe data, regardless of where that data is stored, whether that's a database or another API or wherever. GraphQL is not just for React or JavaScript developers. So GraphQL may be extremely popular with web developers, but JavaScript is not the only language in which you can write and work with GraphQL. So GraphQL can be used anywhere that a client communicates with an API, regardless of the language. So there are libraries for working with GraphQL in Python, Go, Ruby, Java, etc. The list goes on. Here are some of the key differences between REST and GraphQL. So in REST APIs, you'll usually have multiple endpoints. So say you have a content API that gives content for a news website. You might have an endpoint which is /article and one which is /video. The article endpoint will give you article data. The video endpoint will give you video data. In GraphQL, there is only one multi-purpose endpoint. And this single endpoint can provide all the data that that API is concerned with. So if it's a content API, then you can go to /GraphQL to find out about articles, videos, galleries, and whatever else that API cares about. So in REST, you get the same set of fields from an endpoint every single time. So if I'm looking up an article, I will always get the same, say, 50 fields every single time. Even if I only want the title of an article, if I make a request to the article endpoint, I'll probably get the body, the contributors, the categories, the tags, a bunch of metadata, and probably all the stuff that I won't use. So with GraphQL, you get exactly the fields that you ask for, no more and no less. So you specify exactly the fields that you want, and GraphQL will give those to you. And the key concepts in GraphQL are schema and query. So the GraphQL schema tells you what fields you are able to request from the API. And then you write a GraphQL query describing the data fields that you want. It's kind of like a shopping list for all the data that you want back from the API. So you will get back exactly the data that you ask for in your query. So now we've done a crash course of GraphQL. Let's do the BFF software design pattern, which does not stand for best friends forever. It stands for a Backend For Frontend API. So this is a software design pattern that was first popularized by SoundCloud a number of years ago. And it's a design pattern for internal APIs. So I'm talking about APIs that are internal to a particular organization rather than published as a third-party API for the public to use. And so I want to talk about what the Backend For Frontend API pattern is offering an alternative to. And that is the one-size-fits-all API. So this is a monolithic API that is shared between multiple applications or front ends inside of an organization. It most likely wraps the primary data source inside of that organization. So it might look like this, where you have multiple applications all speaking to a single shared API. These applications might have different user experiences or use different parts of that shared API. But because it is a one-size-fits-all API, the API must serve all of these clients equally. So it is a monolith that is a common denominator between all platforms. So it's not necessarily a bad idea to share an API between different applications, but there are some common pain points in this scenario. Firstly, different clients need different sets of data. The one-size-fits-all has to try and serve all of these different needs, and unfortunately, it's almost impossible to provide the perfect endpoint for every single client. If it tries to do this, the monolith is probably going to become increasingly unruly as it tries to keep up with the demands of all the different clients. Secondly, the shared API becomes a bottleneck when rolling out new features. So every time a new feature is required, the front-end team has to coordinate with the API team or the back-end team, which is responsible for the single shared API. This API team then in turn has to balance the priorities of all of the different clients, and because of the nature of software, your priority might not always be the top of the list. So this is where the Backend For Frontend design pattern comes in. So in order to solve the pain points of having one API and multiple consumers, the BFF pattern recommends building one API per client. So that means that each front end essentially has its own custom API, which is built and maintained by the same team as the front end. So it might look a bit like this. So a BFF is created as an interface between each API consumer and a shared API or data resource. The BFF implements API logic that is specific to that particular application. It's essentially a translation layer that ensures data is transformed specifically to suit the needs of that particular client. So clients might be using multiple APIs, in which case the BFF can also act as a kind of API gateway that is defined just for a single application. It will perform the task of aggregating and combining all the data from a set of APIs into a common format that is convenient for the client. So what are the benefits of this? Well, firstly, it's easier to adapt the API as UI requirements change. As a front-end developer, now instead of having to wait for the API team to create a particular endpoint for you or integrate a new field or a new set of data, you now have the power to just go ahead and make those changes yourself. It also simplifies the process of lining up server and client releases. So now that one team manages both the UI and the API, there's no longer coordination that has to happen between a front-end and a back-end team. Thirdly, because it's focused, the BFF API will be smaller than the shared single-purpose API. It'll probably be easier to understand and navigate, and will probably have smaller payloads if it's a REST API. Finally, you're able to aggregate multiple calls to downstream APIs into a single call to the BFF, which is a lot simpler and often more performant. So now that we're on the same page about GraphQL and BFFs, let's talk about GraphQL BFFs. So I want to talk about how GraphQL and BFFs relate to each other. And if you're a GraphQL enthusiast or you listened really well in my crash course, you might be thinking that a lot of the benefits that I just mentioned of a BFF actually sound quite familiar to you. And you would be right, because a lot of the benefits that I just mentioned actually come for free with GraphQL, and there's a lot that is shared in terms of benefits between GraphQL and BFFs. For example, just as a BFF provides only the data that is needed by a client, GraphQL allows clients the flexibility to define their own data needs. BFFs reduce overfetching since a BFF returns only the data for one particular client rather than many clients. And GraphQL reduces overfetching because GraphQL returns only the data that you actually requested in the query. BFFs allow you to combine multiple data sources into one single BFF interface. And GraphQL allows you to combine multiple data sources into one single GraphQL interface. But even though there's a lot of shared ground between GraphQL and BFFs, GraphQL is not necessarily equivalent to a BFF API. Backend for Frontend is a design pattern that was invented before GraphQL, and it might leverage either REST or GraphQL. And GraphQL APIs are not always designed to be a BFF. Sometimes a GraphQL API is built to be shared by multiple applications, and it's built to be generic. But in my experience, GraphQL BFFs are actually very common, and it's a very common way for people to introduce GraphQL to their code base for the first time. So I've heard of many teams introducing GraphQL to their company or project in the form of a BFF that will frequently wrap legacy APIs. It'll frequently aggregate multiple data sources, possibly ease the transition to microservices, or help with migrations between different APIs. And this is my theory about why GraphQL BFFs are so popular. So a BFF is a low-stakes way to introduce GraphQL to an organization. Its surface area is limited to just one application, and it does not require you to actually rewrite any downstream services or APIs in GraphQL. So with this in mind, I'm going to tell you about the GraphQL BFF that I built with my team at Conde Nast. And I'll tell you where we started out, and then I will take you on the journey of where this BFF API has ended up after over 2 years in production. But first, some context. I work for Conde Nast, which, if you've never heard of it before, is the parent company and publisher of some magazine brands that you probably have heard of, like Vogue and GQ. And I always feel the need to clarify when I give a GraphQL talk that GQ is not a magazine about GraphQL. Thank you. It's my only GraphQL joke. So for 3 years, I've been working on a team that builds the international websites for Vogue and GQ magazine, which are all served by a single multi-tenant React application. These sites are currently fully powered by a GraphQL API in production and have been since early 2018. So that's just over 2 years. So the content for a Vogue website needs to come from somewhere. And if you've ever worked for a media company or built any product that needs content, then you will know that the Vogue website must be backed by a content management system or a CMS. And the content for our websites comes from an internally built content management system called Copilot. Copilot has a REST API, which allows you to request data for content such as articles, videos, galleries, etc. Now, when we first started working on the website application in 2017, GraphQL was not really, it existed, but it wasn't really a thing yet. It wasn't on our radar that much, and it wasn't really that popular. So, of course, Copilot did not have a GraphQL API for us to use, and we didn't even really think about it. So we used the REST API and backed our application with this. So before GraphQL, our API architecture used to look something like this in a very simplified form. Our website application, which is written in React, was speaking pretty much directly to multiple REST APIs. And the most important of those APIs was the content API from Copilot, our CMS. So we worked like this with this architecture for about a year and launched the first Vogue site, or relaunched the first Vogue site successfully with this architecture. And overall, it was fine. But there were some pain points that really started to make themselves known the more we started to scale and add more websites to our multi-tenant application. And here are the main problems that we had with the REST API. First of all, the REST API was not always intuitive to use. Some of the fields had really confusing names that we had to explain whenever we onboarded a new developer to the code base. And these abstract names sometimes made our React components really difficult for people to understand. Secondly, we had to make multiple requests to get all the data that we needed. So to render an article, we didn't just need to get the data from the /article endpoint. We were making around 15 different requests to different endpoints of the same content API. We were fetching a wide range of related data, such as categories, tags, and contributor information from different endpoints, and then trying to combine all this data together. So number 3, as you can imagine, we were massively overfetching from all of these APIs. The JSON response for each endpoint often included hundreds of fields, and of these, we would only use a tiny fraction. And unfortunately, we weren't great at filtering out the data that we didn't need. So a lot of this data did end up in the client. Finally, our React components were littered with API-related business logic, rather than being mostly presentational as we would prefer. So this isn't necessarily the fault of the REST API, because we're the ones who put the logic there. But something about our architecture was encouraging quite poor separation of our concerns, and we incurred a lot of tech debt because of this. We needed a clearer distinction between our data layer and our view layer, and we didn't really have that. So to solve these problems, in early 2018, we introduced GraphQL to our project in the form of a Backend For Frontend API, although I don't think we knew that we were creating a Backend For Frontend API at the time. So we wrapped all the REST APIs that we were using in a GraphQL layer. And now the React application, instead of speaking directly to any REST APIs, would speak to this GraphQL layer. And the GraphQL BFF was effectively shielding the React application from having to deal with any of the REST logic together. So our React application didn't have to glue together 15 different requests to make an article. It would just request the article data from GraphQL. Now, people ask how long it takes to switch over to GraphQL. And of course, this depends on the size and complexity of your application. But for us, it took about 3 months. So we integrated our new BFF API incrementally, making the switch literally page by page. So we started with a category page, as you can see, and we ended with the home page. And by the end, our websites were 100% powered by GraphQL. and all data that is required for the site is accessed through a single GraphQL interface. And people also ask what the most challenging part of switching to GraphQL was, and for us, the most time-consuming part of this whole process was ensuring that all pages were covered by really comprehensive acceptance tests, so that we could ensure that there were no regressions when we turned on the GraphQL feature flag. And we did break the article page about 3 times in this process, but we learned from our mistakes, and we got there in the end. And so now we're fully powered by GraphQL, and we have very comprehensive acceptance tests to make sure that we don't break things. So here's what GraphQL gave us. Firstly, it gave us a really nice, intuitively designed API. No more confusing names or confusing deeply nested relationships. We designed it in a way that actually made sense to us as product developers and was human readable. Secondly, we gained the ability to fetch only the data that we actually needed. So no more overfetching, because we could specify exactly the fields that we wanted, and we didn't have to filter through hundreds of lines of unnecessary data to get what we actually wanted. And we could do all of this in 1 request instead of 15 requests. Thirdly, we now have a single interface to interact with multiple downstream services. So our React application now does not have to care about the distinction between multiple REST APIs and request data from them separately. Components can now request the data that they need regardless of where that data comes from. It can focus on being the presentational layer. Finally, we gained components free of API-related business logic. GraphQL really encouraged us to clean up a lot of our tech debt around this. And the data transformation that we were previously doing inside of our components was now delegated to the GraphQL layer, leaving the components to focus solely on presentational logic. So we loved our new GraphQL API. Honestly, we were a bit obsessed with it. And it was a really successful development in our architecture that made everyone working in the code base extremely happy. So it encouraged us to clean up a lot of our tech debt. We felt really confident in our application. And newcomers to the code base were way less confused, because instead of us following internal patterns that we had created ourselves, we'd used a pattern which was open source and something that they could easily familiarize themselves with. But for now, the API that we've built is just being used for a single application. We'd created our own personal Backend For Frontend API. And to foreshadow the next section of my talk, I will say that we always had a slight feeling that perhaps someday this API would come in useful beyond the confines of just our application. And we did keep this in the back of our minds while we were designing our initial schema. So we have this GraphQL BFF API, which we love. Now what happens next? So this section of the talk is going to focus on some of the dilemmas that you might find yourself having once you've actually built a GraphQL BFF. I'll tell you how we scaled our GraphQL BFF and how we've ultimately evolved it into something that goes a little beyond the Backend For Frontend design pattern. So before I go on, I want to stop here and be a bit philosophical and talk about one of the most common criticisms of the BFF pattern, which is duplication. Already there's some risk of duplication in the GraphQL BFF that I just described. We're essentially re-implementing a shared content API, and if another application in the same company, perhaps, wrapped the same API in GraphQL or built a GraphQL BFF wrapping this API, then our code would probably look pretty similar. And I think that as developers, we are naturally averse to duplication. We are obsessed, sometimes and often to a fault, with making everything as dry and abstract as possible all of the time. We really love abstraction and will often aim to create a shared component, function, or service to avoid doing something more than once. So for many of us, BFFs will feel counterintuitive because duplication is kind of inherent to the BFF pattern. So Sam Newman, who was speaking at this conference, hi Sam, if you're in the room, he said, one of the concerns of having a single BFF per user interface is that you can end up with lots of duplication between the BFFs themselves. They may end up performing the same types of aggregation or have the same or similar code for interfacing with downstream services. Some people react to this by wanting to merge these back together and have a general purpose aggregating edge API service. This model has proven time and again to lead to highly bloated code with multiple concerns squashed together. So that's a damning review of creating abstractions out of a BFF. If you Google the Backend For Frontend pattern, you will find Sam Newman's iconic blog post from which this quote was taken. Now I want to share another quote which I really love by Sandy Metz, which is, duplication is cheaper than the wrong abstraction. So I really love this quote, and ever since I heard it, I think about it every time I go to abstract something out into a function or abstract something in some way. I've been burnt by creating the wrong abstraction too many times. And after being burnt, I really believe that when we design code and services, we should always start from a place of duplication wherever possible. We should optimize later down the line once we've validated the actual need for a particular abstraction and validated that it is the correct abstraction. And I'm talking about this philosophy because on our GraphQL BFF journey, we did ultimately create an abstraction to try and fix some of the duplication that was inherent to our BFF. But I don't suggest that you do this without really questioning first if your abstraction is really necessary or if it is the correct one. And don't create a shared microservice before you actually need one. So there are costs associated with creating a shared abstraction, or in the case of what I'm going to talk about today, a shared service. Once you start to share something with other developers, the stakes have risen and you have acquired essentially a burden. So the first cost is that you now have less ability to take risks and try out new things whenever you want. So your decisions now affect more than just your own application, and you might not be able to change things as frequently as you would like. Other people are now depending on your API to be stable and not break their application. Which leads me to the second cost, which is you actually have to be careful, I would say extra careful, not to break other people's applications. So 5 minutes of downtime might be fine for you and your team's application, but it might be critical for another application in the organization. So when you start to have a shared abstraction, you really need to create a strategy around breaking changes. That's not to say that you should absolutely never create a shared abstraction. So assuming that you have done all of your due diligence, and you've decided that the costs of sharing a service or an abstraction are worth it in your particular case, then there are some compelling advantages. The first one is, of course, less duplication of efforts. So now that multiple teams aren't building the exact same thing, hopefully developers will have more time to work on other, perhaps more impactful projects rather than duplicating the same efforts. Fix once, benefit everywhere. So now if there's a bug, it can be fixed all in one go. The same goes for features and improvements. You might benefit from an edge case found by another application or gain a feature that you would not have thought to actually build yourself. Finally, you'll gain organizational alignment. More teams in the organization will now be doing everything or things in the same way. So that opens up opportunity for collaboration. In the case of GraphQL, having a shared schema is really valuable because it means that teams will now have alignment on naming, which, as we all know, is a very difficult thing. So with that in mind, I'm going to talk to you about how and why we scaled our GraphQL BFF at Conde Nast, and I'll tell you about the shared abstraction that we ultimately created. So when the question came up early last year of what was next for our GraphQL architecture, we had been using our GraphQL API in production for about a year. We were using our API to power a platform that is serving 21 different websites in 10 countries across the world. So that's International Vogue and GQ websites. And our GraphQL API was serving around 200 million users each month, which is a big number. So by all accounts, our GraphQL API was quite successful. So why did we feel the need to actually scale beyond what we were already doing? So when we first built our GraphQL API, we were kind of rebels because it was 2018 and GraphQL was not as popular as it is now. What we were doing was considered experimental, and we really had to prove the technical value of what we were doing. We had to fight against the perception that we were introducing a new technology for vanity reasons that didn't deliver any actual business value. But now in 2020, it's a very different world for GraphQL. GraphQL is skyrocketing in popularity, and everybody wants to work with GraphQL APIs. And we started hearing from other engineering teams at Conde Nast that they were thinking of introducing GraphQL to their projects. So we had wrapped the REST content API that we used in GraphQL. We'd spent time designing a schema that we really liked and that made sense to us, and we had validated this schema in production for over a year. And it did seem kind of a shame to keep this to ourselves, because other teams in the business were still using the REST API that we had found difficult to work with. We even discovered that there was another team building their own GraphQL wrapper around the exact same REST API, producing remarkably, and I would say eerily, similar results. So with this in mind, it came time to think seriously about abstracting out the part of our BFF that actually made sense to share with other people and would be useful to many teams in the organization. So this is the new architecture that we introduced. We decided to split our GraphQL API into two: the core content API and the BFF. It was clear to us that the content-related fields in our schema would be useful to other teams. So we decided to create a core content API, making GraphQL a first-class citizen for any application requesting data from our content management system Copilot. We'd already written a schema and resolvers wrapping that REST API for ourselves, but now we wanted to make this available for other teams to use as well. But we still felt that there was a need for the BFF. The core content API could not serve all of the data needs of our React application alone. There are some parts of our schema that were not content-related. They were quite specific to our particular application, things like configuration or integrations with some other third-party APIs that went via our BFF layer. So we decided that resolvers for these things would remain inside the BFF schema for now. So here's what our architecture looked like before we split out the content API into its own service. As you can see, the GraphQL BFF is speaking directly to the REST content API as well as some other APIs. And here's the change that took place. Now our GraphQL BFF will actually consume a GraphQL content API directly. The logic required to wrap the REST API has now been moved into its own service. And the BFF will consume pure GraphQL content data. So now that GraphQL service can be used by other applications in place of the REST API. It's now been elevated to the very esteemed status of being an official published GraphQL API for the content management system itself. And a big part of the dream of this new architecture is that we would be consuming GraphQL all the way down. So instead of carrying the complexity of wrapping the REST API inside of our BFF, we could just consume pure organic GraphQL direct from the source from our new service. So let's talk about implementing this new architecture. Here's what we need to do. We need to build a new content microservice. We need to integrate this microservice back into the existing BFF. And we need to do this incrementally and crucially without breaking 21 production websites. And first of all, the building. And here's a lovely team photo. So I was part of the team that we actually look quite angelic with this light behind us. So I was part of the team that built this new microservice. But because this microservice was now going to serve the entire organization instead of just our particular team, we assembled a team with engineers from across multiple areas in the business to build this together. So the team included myself and some other people from the team that had built the GraphQL BFF that I've been talking about. But the team also included some engineers who were working on the other GraphQL BFF that was wrapping the same REST API. And the team also included some people who had worked on the REST API itself. So it was a pretty solid mix of experiences for this team. So as a developer, it is quite a rare opportunity when you're given the time and space to improve on something that you've built. And this time, the challenge was different. So the challenge this time was to take the schema that we had already used in production for over a year, and we needed to make it generic enough to be shared by applications other than our own. So although this new GraphQL service is representing pretty much the same content data as what was in the BFF, we now have the license to make improvements with hindsight in mind. So we can take all the learnings and pain points of using our schema for over a year in production and actually make something better to be used by other people. We also have the added insight of engineers who worked on other relevant teams and have experienced use cases that we did not experience on our team. So we built it. This is it, the core content API. So we spent a few months building it. And then there was the final challenge, which is to integrate this new content API back into the existing BFF schema. Now, as a reminder, here's what our application architecture now looks like. The new GraphQL content API may replace parts of the BFF schema, but the BFF is still very much the GraphQL point of entry for our application. There is data from other sources that is still represented in the BFF, as you see from the other REST APIs down the bottom. And here's what we want in order to integrate with the new microservice. We need a way to forward or proxy content queries through to our new content API via the BFF. And we need the ability to integrate with the new content API incrementally. So if you're familiar with the GraphQL space, you might know that there is a new open source tool from Apollo, who is the dominant player in the GraphQL space. And this tool is called Apollo Federation. Federation is Apollo's answer to implementing GraphQL in a microservices architecture. It's replacing schema stitching, which has now been deprecated by Apollo. So I'm personally quite excited about Apollo Federation, and I would like to use it. But when we looked into using Apollo Federation for our purposes here, it didn't seem quite right for our use case right now, while we still have the BFF schema. And it would probably require a bit of an architectural shift for us to use it. So even though we'd like to use that eventually, what we really wanted right now was a minimal way to get started querying this new content API without having to re-architect any further. And we were happy to go with something imperfect and iterate on it later. So we ultimately chose something called schema delegation, which is a method made available by Apollo. Basically, it's a way to forward GraphQL queries from one GraphQL service to another. So you set up what's called a remote schema, and you delegate queries to that schema to be resolved. So in this diagram, you'll see the content GraphQL microservice is our remote schema, and we delegate all content-related queries to this service to be resolved. Any non-content-related queries to the BFF are resolved locally by the BFF. So this option was a little bit messy for various reasons that are too niche to go into, but this approach got us forwarding content queries through to our new service with minimal effort and pretty minimal code changes. Most importantly for us, we were now able to integrate incrementally. So much like how we initially released GraphQL, we set up schema delegation per content type, so we could switch the feature flag on page by page. And what are the results of all of this? Well, we now have a Vogue article that looks exactly the same. Wow. The plight of a back-end developer. Except underneath the surface, unbeknownst to all the readers of Vogue Germany who want to catch up on the German Fashion Week news, the article data is now coming from a different place. So instead of the article data coming from the BFF, that data is now coming from a beautiful content microservice somewhere else. And the developers that work on this application might now have some more free time to work on other features that readers actually will see and notice on the front page. And they're much happier, because now they don't have to maintain all that local resolver code. Well, that fantasy isn't quite real just yet. This is actually still a work in progress, and we're still in the process of migrating over to using the new content microservice. But in the meantime, several other engineering teams at Conde Nast have also started to use this new service. So it's already validating the model that we were going for. The other team that had also wrapped the same GraphQL API, the same REST API, are now using this GraphQL service. So that's pretty cool. So now the final section, the future of GraphQL architecture. So I've shown you how my GraphQL architecture has evolved, but I have some ideas about how it might evolve even further in the future. So I want to talk about where GraphQL is headed this year, starting with some industry trends. Industry trend number 1, GraphQL adoption is growing, and many more APIs will be built with GraphQL in 2020. So these are the results of the State of JavaScript survey in 2019, which has 21,000 respondents. So in 2016, 5% of JavaScript devs had used GraphQL. Compare that to 2019, 39% of JavaScript developers had used GraphQL. In 2016, 36% had never heard of it, but now in 2019, only 5% had never heard of GraphQL. So I expect these numbers to continue growing in 2020. Industry trend number 2, GraphQL architecture is moving towards federated microservices with Apollo federation. So when I was at GraphQL Summit last year, this was a really clear theme and a really clear takeaway from the conference. And nearly every speaker from a large organization using GraphQL spoke about their architecture evolving in this way. GraphQL APIs are becoming a set of federated microservices. The ideal GraphQL API of the future will be an API gateway that allows you to query seamlessly for data from multiple different microservices. I think that it's a natural progression as organizations are starting to scale their GraphQL APIs. Engineers are finding that a monolithic GraphQL API needs to be split out into microservices to be worked on more efficiently, or they're finding that people have built GraphQL services all around the organization, and it would be convenient if they could share schema. So Apollo Federation has been out for about a year now, and given Apollo's enormous influence in the GraphQL space, I expect that this will become industry standard. And personally, I would really like to start using Apollo Federation. So the final industry trend of note is that GraphQL architecture is moving towards one universal data graph per organization. So this is kind of related to the former trend. Organizations will seek to combine all of their GraphQL services into one common data graph shared by everyone in the organization. And it will look something like this: a data graph for the entire organization, a gateway to every GraphQL microservice that is owned by that company. Teams are able to query for any data that the organization owns, and which is in GraphQL, in one place, and seamlessly combine data from multiple different places. So where does this leave our humble BFF pattern? Well, with GraphQL becoming more widespread across organizations, GraphQL architecture patterns are ultimately evolving beyond the BFF pattern. But regardless of this, I still think that if you are introducing GraphQL to an organization for the very first time, or you're a very small organization, then the BFF pattern is still a good place to start. You may ultimately evolve it into something bigger, but when you do, you will be informed by real-world usage. And thinking back to what I said earlier about the similarities between GraphQL and BFFs, here's what I think now. GraphQL is not a like-for-like replacement for a BFF. But it solves enough of the same problems that if you evolve your architecture towards consuming pure GraphQL microservices, you might find that you no longer actually need a BFF. And what do I want? Michelle Garrett of Conde Nast. What do I want our architecture to end up like? So with these three trends in mind, this is the architecture that I personally would really like to move towards. I'd like to get to a point where we could remove the existing BFF and speak directly to a single universal Conde Nast graph that is backed by GraphQL microservices. If we have the ability to get all of our application data via pure GraphQL from a single endpoint, then there's no need to keep our application level BFF. I think that the BFF will be useful for a while, and it will probably be a while before we remove it. But if we convert the wider organization to building APIs GraphQL first behind a gateway, then ultimately I think we might grow out of this pattern. And now, much like this turtle, I don't want to rush the process of evolving our architecture. I want to be thoughtful about how we scale our GraphQL, and I would like to continue validating all of our abstractions before we make them. Now I have two closing thoughts and takeaways from this entire GraphQL journey. The first one is that I really believe in focusing on incremental change. And we've done this throughout our entire GraphQL journey, and I think that it's proven to be very important. So you may dream of having an ultimate GraphQL gateway of microservices, but if you're evolving the architecture of a production application, then this isn't necessarily realistic, and you need to start smaller. Big bang releases are risky, and if you build something for too long in isolation, you might build the wrong thing. So try and get in production as soon as possible, and keep going even if it's not your ideal solution or architecture. And related to this, don't optimize too early. We could have built our content API as the generic, official, organization-wide API in the first place, but we built it first just for one application. And I think that ultimately, we created a better API because of this. Because by the time we went to design a replacement for the REST API, we had a year of learnings and product experience to inform this. We were also able to take more risks along the way, as we didn't yet have the burden of supporting other clients with a published API. And that is the end. Thank you for having me, and good luck on your GraphQL journeys.